Okay, this is the encryption module for Redot Engine. In it, I have implemented RSA and AES. In the video description, we'll include a link to the example code that I wrote. As of recording this, it is currently in the experimental build. So, as I mentioned, I've implemented both RSA and AES. I've designed for easy out-of-the-box use. Even if you don't know anything about cryptology, you can still use it with relative ease. Okay. Let's start with RSA. It's pretty straightforward. We generate two keys, a public key and a private key. You can export either key or import another key. You can encrypt with either the public key or decrypt with your own public key. And you can, of course, sign with your private key and verify with a given public key. So let me run this and explain exactly what's happening here. So first, you're going to initialize the module here. In this specific code, we have I generate a key pair. You don't have to do this, but if you want, you can specify a bit size. The default is 2048 bits, but you can go lower to 1024, but it will complain about how weak your key is. I really recommend that you do not do this. 2048 is considered the standard, but you can also go higher to 3072 bits or 4096. You don't need to really worry about picking a key, though, if you don't want to. In the next set here, we're exporting the keys, the private key and the public key here. You can see that. Let's see, let me actually run this. So notice that whenever it prints out the public key and the private key, here's the private key here. It's in PM standard, which means that you can use it outside of Redot, and same goes for the public key. We're printing out some plain text here, and let's see, here we're encrypting. It's just encrypt. Now you'll notice that there is true included in the parameters. The reason for that is so it defaults actually to true. You can also put in false. False will set it to the imported key. So if you were to import a public key, it would encrypt the message or given plain text using that key. And then, of course, with the decrypt method, you can actually only decrypt using your private key. So, yeah, there it is. And so you see here, this is what it looks like when it's encrypted. It's in base 64, and the reason for that is because it's easier to deal with outside of Redot. And here, you can see that it works with the decryption. It prints out the exact same message. Okay, now let's shift over to the basic AES subroutine or function. You initiate the module here. You generate the keys, or the key rather, and you can decrypt and encrypt based on a given mode. So first, I do want to point out a major difference here between the RSA module. So in generate key, it actually returns a string instead of just generating a key and keeping it in the background. You don't have to worry about it. And the reason for this is because I wanted to make sure that it was very easy for you to be able to generate new keys. Also, another important bit of information about this specific string with the key is that it is in hex code. I thought that this was probably the easiest way to be able to send this key around. So that's how we did it. I'll also mention that there is, with the encrypt and decrypt function here, there is a mode that you have to select, or have to select. You don't really have to. We have defaults already set in and everything, which I use GCM, which I'll explain in a little bit. But the mode is a component to encrypting and decrypting everything. So the quick rundown here is that while you can select a mode, CBC, CTR, and GCM, it does default to GCM for you, so you can ignore the modes and you don't need to worry about those things in case you don't want to bog yourself down with, what those mean and worry about those things, because as a game developer, you probably shouldn't have to worry about encryption and all that stuff, which is pretty much the goal of this entire module, right? With that said, I did want you to have the ability to fine-tune, the encryption that you wanted to have. You can look into all these things, and it's pretty simple to literally just Google AES dash the mode that's listed right here, right? Okay, so let's go ahead and run this. So as you can see, I actually looped through the 3 different modes so you can see how they come out. I didn't print the plain text for once, but you can see the decrypted, which is basically just the plain text. And as you can see, AES CPC encrypted, here's what it looks like. CTR, here's what it looks like. GCM is what it looks like. You notice that there are very different sizes and all that kind of stuff. Again, this is explained if you were to look up what the different modes mean and everything like that. But I imagine that this is very self-explanatory. Okay, so with this overview, you might be wondering why you would use both. Like, why would I use either of them? Why wouldn't you just use RSA, right? Because it's quicker, it's easier, da da da. Well, both have their own strengths and weaknesses. RSA is very secure, but it cannot encrypt anything larger than its own bit size, and it's also just generally very bulky. AES, on the other hand, is very fast, but it's not as secure unless you can hide the key. So I wrote a demo where you have both interacting with each other, right? I wrote a fake server and a fake client. Again, you will be able to review this if you go down in the description and check over the code, client.gd and server.gd, right? So the variables in each one are separate from one another, so we're going to just pretend that they're on a different network, and the saved files are actually just packets, because the way that I wrote this, I envisioned, client-server relationship sort of situation, right? Now, on both server and client, on the server and client network, I've initiated both of them right here, as you can see. The initialization aspect that generates their keys and everything like that, and of course, you do want to save them, and in that, it's set up to be, they're just saving locally, but they're set up to be as if there were packets, and they save it and everything, and then in this one, they're loading each other's pub key, because remember, like I said, with RSA, you encrypt with the public key, and you decrypt the private key, right? And you do not share your private key, hence the name private key. Now, afterwards, the server is going to generate an AES key, and then it's going to encrypt that key using, right, the client's RSA key, public key, and then it's going to send it out. And then the client is going to obtain said key, decrypt it using its own private key. And now the server and the client can talk to each other using that AES key. Remember, it is one key. So that key both encrypts and decrypts back and forth, right? So the server writes a message, sends it out. The client obtains it and decrypts it here, and then it'll read it. It'll print it out. I'll run this in just a moment. The client will decide, I want to respond to that message, and encrypts the message with that given AES key. And then it sends it out, and the server obtains it, decrypts it using the same AES key, and then reads it. Now let's see how they interact with one another. Right? So this is the AES key. Apparently, this is. Hold on, I actually did that wrong. I need to comment this out. Do this because I am really dumb. But let's run this again. Alright, so you don't see any of this stuff happening. This is a lot of the stuff that's happening in the background. The initialization, the saving, the loading, etc., etc., etc. The client, like from the client's perspective, the only thing that really matters is it's seeing the message that the server decrypted, right? And then from the server's perspective, it's got the message from the client here. Right, and there you go. That's an example of how the cryptography module can work in Redot, and there are obviously a lot of different use cases that you can have with it and everything. And again, this is just an example of how it could be used. So yeah, there you go.
Thanks for checking out this video by one of our developers. If you like what we're doing, please give us a like and subscribe, and we'll see you next time.